Okay, so we're on section 3.3, and what I'm going to do is, this is going to go really fast, okay, because you've essentially learned all of this, but basically, anytime you are asked to convert from one unit to another, and moles is somehow involved, you're always going through the mole. This chapter, or this book, actually uses the wheel model for mole conversions. And just to give you an example, if you're given grams of something and you're asked to solve for items of something, and remember that items would be things like ions, molecules, formula units, or atoms, you have to go through the mole. So that means we are going to convert to moles and then convert moles to the other unit. And here they're showing you that you can convert grams to moles by using the molar mass, and then you can convert moles to items by using Avogadro's number. Now, I believe I need to give you the Chapter 3 review packet, which would show you some basic math setups, which I'm going to write out for you in a little bit, just to give you an idea of how really the setup is the same every single time. So let's go to the next page. And on the next page, I'm going to give you some basic setups. So why don't I write these math setups down here for you, okay? All right, so let's say that you are given grams of something, okay? So that number would go here, and the unit would be grams of A, whatever A is, okay? An element, a compound, a molecule. Then on the diagonal, you would put the molar mass of that substance here with grams and the substance formula after it. 1 mole would always be on the top, okay? And then if we're going to convert from moles to items, you would put 6.02 times 10 to the 23rd here. So this is your items or your things of A. Obviously, you would have to replace the letter A with the appropriate chemical formula or symbol. Obviously, you would replace items with formula units, molecules, atoms, ions, whatever it is, okay? And then this is how you would get your items of that substance, okay? Now, I could also go in the opposite direction. If I'm going in the opposite direction, then I will be given items of something. So you would have to put that unit with the formula here. This time you would divide by Avogadro's number, and you would put a mole on top, and then we would convert moles to grams here, and that's how you would solve for grams of a substance. Now, just want to remind you that a lot of times they're just going to ask you to solve for the mass of something, and if they're asking you to solve for the mass of something, it's typically implied that that means grams. They would tell you otherwise if it was something else, like kilograms, okay? But all I'm doing here is bringing together each individual step that you learned in section 3.2, and I made 2-step problems. That's it, okay? So you might see kilograms given, which you'd have to convert kilograms to grams, or you might see kilograms down here as something that you're solving for, so you go grams to kilograms, okay? So once you get that done, written down, then we're going to take a look at the practice problems, and then I really only have one more thing to teach you in this little section, and then we're done with 3.3, okay? Okay. Okay. Marco, we're good? Can I go on? You got it? Okay. Okay. Let's go right here. Let's take a look at number 2. They want to know how many atoms are in 2.1 grams of bromine. So here you are given grams, and then we're going to solve for atoms, and atoms is a item or a thing, right? So we're going to write 2.1 grams of bromine first, and then I'm just going to highlight units as we go just to remind you that these are the units that we're canceling. Grams of bromine goes on the diagonal, okay? Because we're trying to cancel it. 1 mole of bromine goes on the top. We put the molar mass here next to grams. If you look at your periodic table for bromine, bromine's molar mass is 79.90. Okay. Then this moles of bromine is going to follow us onto the diagonal because we're trying to cancel it. Okay, so the number 1 goes next to moles. We're going to atoms, which is an item or a thing. So we're going to put atoms of bromine here. And then you put Avogadro's number in front of it. So this is 6.02 times 10 to the 23rd. In your calculator, this is 2.1 divided by 79.90 times 6.02 second E23. Again, be really careful when you put stuff like this in your calculator. This is in standard scientific notation, so you will not put the extra multiplication symbol in there. You would just do the 6.02 second E23. 2 sig figs is the fewest sig figs that I have here. Therefore, we will have 2 sig figs in that result. I got 1.6 times 10 to the 22nd. Did you guys get that? If you're off by 1 decimal place, it probably means you accidentally put an extra power of 10 in there. Or an extra multiplication symbol in there somewhere, yeah.
This is kind of similar to this, but for calculating molar mass, is it always to the hundredths?
Yes.
Okay.
Okay. Do I need to do another one of these, or do you understand with the math setups? Yeah? Okay. So then let's go on to mole ratios within formulas. Okay. Now, if you have a compound, you know that they're made of 2 different elements in the periodic table. And so what we're going to be doing is we're going to take a look at converting to moles within the formula. Okay, so what we're doing right now is called stoichiometry. Stoichiometry deals with the quantities of substances that you have. So like the relationship of a quantity of one element to another. And sometimes we'll convert between reactants and products in chemical reactions. We won't get to that until we get to chapter 4. But let's take a look down further at the bottom of the page. And I'm going to introduce mole ratios within formulas. So let me give you an example. Let's say we're looking at carbon dioxide. Okay. If I have a mole of carbon dioxide, how many oxygens are in the formula for CO2? 2. So a mole of CO2 equals 2 moles of oxygen because there are 2 moles of oxygen inside of it. Okay? I can do the same thing with carbon. I can say in a mole of carbon dioxide, since I have 1 carbon in that formula, this would be equal to a mole of carbon. Okay, so these are just ratios within the formulas that I can use to convert to moles of that particular element. Does that make sense? Okay, so let's go to the next page, and I'm going to show you a couple of examples for using this stuff. So, did it go to the right page or did it go too far? Too far. Here? Yeah. Okay, so let's take a look at these sample problems. They want to know how many moles of hydrogen are in 6 moles of water. So you are given moles of water. So that's why this is written here. Okay? Moles of water is on the diagonal. They want us to solve for moles of hydrogen. So that's why moles of hydrogen is up on the top. There are 2 hydrogens in water. So that's why they put 2 moles of hydrogen over 1 mole of water. Here you're multiplying across 6.0 times 2. That's how they got 12. Since you can physically count the number of hydrogen and oxygen in the formula, these are exact. So these have infinite sig figs. This has 2 sig figs, and this has 2 sig figs. Does that make sense? Okay. Okay, now let's do another example. Let's take a look at the sample problem at the bottom of the page. Down here at the bottom of the page, they're asking us to solve for moles of methane, but they gave us grams of oxygen. So here, you're given grams of hydrogens. This is given. And then we're solving for moles of methane. Okay, so the grams of hydrogen is here. That's what we start with. Grams of hydrogen goes on the diagonal. This number right here, this is the molar mass of hydrogen. Technically, it would be 1.01. Okay. You put 1 mole of hydrogen on the other side, and then moles of hydrogen needs to follow you onto the diagonal because that unit needs to cancel. This 4 right here, this is the number of hydrogens in the CH4 chemical formula, okay? And then we can solve for moles of CH4. In your calculator, this would be 0.860 divided by 1.01 divided by 4, enter. You have 3 sig figs here. This number 1 and this number 1 are infinite. This number 4 is infinite because you can actually count the 4 in CH4. This is 3 sig figs. That's why they have the wrong number of sig figs. This should be 3, whatever that comes out to be. Okay? Let's take a look at the next page. Yeah, this should be 0.213. Technically, okay? Okay, on the next page, we're going to look at the sample problem as well because that one's slightly different, okay? Does everybody have this? Yeah. Let's go here. Okay, so for this one, they want to know how many grams of oxygen are in 14.6 grams of CO2. So here you are given CO2. We're solving for grams of oxygen. Grams of CO2 is here to begin with because this is what we are given. You put grams of CO2 on the diagonal because we're trying to cancel it. This is the molar mass of CO2 with the number 1 on the other side. Moles of CO2 has to follow you onto the diagonal because you're trying to cancel it. And then this number 2 moles of oxygen, this is the number of oxygen in CO2. So you're doing your mole ratio within the formula here. Moles of oxygen follows you onto the diagonal. And then this is the molar mass of O. Okay, notice it's not multiplied by 2 because it's not diatomic. It's not pure oxygen, it's oxygen inside the chemical formula. So this right here, this is your mole ratio within the chemical formula that allowed us to get to grams of oxygen, okay? In your calculator, this is 14.6 divided by 44 times 2 times 16, enter. Okay. And then what we're going to do is we're going to do some practice problems, and then we are done with this section. Okay. Okay, let me stop this.